So for our upcoming exam 4, okay, here's all the conceptual stuff. And if you can answer pretty much all these questions, there won't be any surprises on the exam. Now realize for this exam, right, not every single possible question is in there, okay? But in making up the exam, I looked at all the homework, all the in-class problems, right, all the quizzes, and everything's taken from there. So we have our constants, you're given that. How do you know when a reaction or a process is spontaneous? Connor, how do we know that in this class? When delta G is negative. Right. I think there was, I could finish that question, Anessa, with another homework question also said, interpret the sign of delta H. What did that mean? Endo and exo, exactly, because it said interpret the signs. Remember that you had to calculate delta H. Well, you're really calculating, right? With a little superscript 0, that meant you used the tables, right? So negative was exothermic. Cameron, how do you, when do you use this? When do you use that? This is way back in the beginning of the exam 4 material. Delta G0 is delta H0 minus T delta S0. When are you going to be using that? Yeah, everything has to be standard conditions. Where this is coming from, I don't know if you remember doing this. What this is coming from is they gave you tables, right? And it was really silly because there's delta G0 tables. Why use delta H0 and delta S0 table to get a delta G0 when there's a delta G tables? But they forced you to do it. Remember that? So there was one trick in doing it, though. Remember what I'm getting at? Anybody remember? See what I'm getting at? So you had to find. You had this reaction. You had to do delta H for products minus reactants, delta S for products minus reactants. There was a unit trick. You had to convert kilojoules to joules because delta H is in kilojoules. Or convert the delta S table, which is in joules, to kilojoules. So there was that trick that you had to do to get the right answers. Because you can't take kilojoules minus joules, right? It had to be joules minus joules or kilojoules minus kilojoules. Okay. How about, so that's pretty much all I have for that one. Bless you. How do you reorganize this to get K? Jose, how do you do that? How do you reorganize this to get K? What?
G over R.
Good. He brought the, let's bring the negative sign over too.
Yeah.
Then, yeah, that was the very first step. Perfect. Wait. Okay, Enrique, he's got it pretty much done. Where's Enrique? That bum. Andrea, Jose pretty much has half of it done. What do you do now? Yes, get rid of the ln. There's a function that's inverse. It'll cancel it out. E, raise it to the E. Right? How do you write E? Come on. E to the ln k. They cancel out. Right? So k would equal e to the negative delta G0 over RT. Here, where do you typically get values to plug into this equation? Mia, where do you get values to plug into this equation? E0 cells, E0 cathodes plus E0 anodes. The chart. right? And how do you pick? Sometimes they're not going to be obvious, Alyssa. How do you pick? Now, remember the chart she's talking about? Mia's talking about that chart where you had all these reactions, and they had electrons in there, and then you had volts on this side. Remember that? Okay. How did you pick which half reaction was the cathode and which one was the anode? Right? Because these E zeros are just volts, and we just add them up. How do we pick?
Isn't the cathode when it gets flipped or oxidized?
The cathode, I think of it this way. The only way I can remember this is anode and oxidation both start with a vowel. So anode's oxidation. So cathode must be reduction. And these tables are what potentials? Reduction potentials. So the cathode's the one you're not going to flip. But Alyssa, we never really even cared about the names, right? We never really called one cathode or anode. Unless you had to draw the nice pretty picture. That's coming up. You had to draw those nice pretty pictures. Then you had to label a cathode anode. But we never really cared which one's cathode anode. How do you know which one you flip without even naming them? Oh, good. Mia's onto something. You may not have a choice. If they give you the reaction, you don't have a choice. If it's to go from one to the other, right? Because you have to add up these half reactions to get the overall reaction. So if they give you that, you have no choice. You don't do any flipping at all. So all of it's done. But if they give you two half reactions, you always flip the one that's the most negative, right? But if they give you an overall reaction, you can't do any, you have to make sure you add them up so you get the overall reaction. And we'll do some of these. How about this next question here? Audrey, we have W max is minus NF E cell. And the question, I'm sure, is find W max, right? Well, where did you get the N, the F, and the E cell?
The F is the 96.
Good. That F is that constant, 96,485. E cell is the volts. If you remember volts and E cell, that really helps a lot. Okay, now you got to get the N. Now remember this E cell, they're pretty much going to tell you, right? And these types of problems, they usually tell you what E cell is, what that little voltmeter's reading. How about the N? Connor, what is it? Yeah, you get it from a half. It's the moles of what? N has to be the moles of electrons. The big hint to me is this. That F is coulombs per moles of electrons. You have to cancel out the moles of electrons. So you have to figure out in this process of W max, right? There's some reaction inside the battery or somewhere, and you have to use what they give you to convert it to moles of electrons. And how do you get it? You get it from what pretty much Connor said. Connor said, hey, you pick out that half reaction. You don't even need the overall reaction, right? Just find that half reaction. And then maybe there's, I don't know, iron in it or something, right? The point is you have a mole bridge between your compound, come on, between your compound and the electrons. Because they're going to say 3 grams of iron were consumed, right? What's W max? The voltage of the battery or whatever is 2 volts. So you know what everything is. You just got to convert those grams of iron into moles of electrons. Plug it in for N, and you get your W. And then, Steph, you don't want to lose a point. You go through all that work. What units do you put on W? Joules. Yeah, it's energy. Work is energy. Okay. We've got delta G0 is minus NFE0 cell. Megan, where do we get numbers to get this? Now, the question before you get tell me where you get the numbers. The question is more like, find the standard Gibbs free energy, or delta G0, from these standard reduction potentials, right? And they give you this mess of stuff. So the delta G0 is what you're after, so you picked out this equation. Where do you get the rest of it? From the two half reactions, you'll get the E0 cell, right? Add up cathode, anode. That's this reaction in purple. So definitely. F is that constant. Where do you get the N? The electrons that cross out, that cancel out when you add up those two half reactions. Exactly. Okay. So notice how this, I think, is the reason why I'm bringing this out. It is really confusing. It is to me. That's the same darn N, right? They're both moles of electrons, but one is W max. W max is, it depends, work. You can do varying degrees of work, right? You can do a little bit of work, a lot of work. So that N is going to change on you every single time. This N in the delta G0 equals minus NF E0 cell, these are all standards. You have no choice. That N is fixed because delta G0 is fixed. Delta G0 doesn't change from day to day. You can't do a little bit of delta G0, a big, no, it's a fixed amount. It's like a height. I'm going to raise it 10 meters. You always have to raise it 10 meters. Right? There's nothing in between. Okay, here's another math one. How do you get K out of that mess, Bowdy?
Well, you have to move the 0.0592 and add 305, so you flip it.
So you'd flip it, so you'd have E0 cell. And what's on top with E0 cell? The N. And that 0.0592 is down here. Okay. Halfway there, Kenneth. Now what? How do you get that K?
You put 10 to be E cell over 0.0592.
Yes. Raise both sides of the 10 power, because then the 10 and the log cancel out. Right. And they cancel out. So you get your K. Okay. So you're going to use that equation when, hey, what's the equilibrium constant, right? And find your equilibrium constant from standard cell potentials. And you'll get E0 cell. How? Pretty much with that same equation up there, that purple one. What would N be again, Andromeda? What would N be in this expression? The moles of electrons. And how do you get it? The half reactions. Cross out again, right? Moles of electrons that cancel out. Okay. Anessa, I think out of this entire exam 4 material, I find this the most interesting and the most intriguing equation. And you can make a lot of money out of it. What am I driving at? What am I getting at? What application? When is this thing used? If I could develop a little sensor, and it's right there on the steering wheel, and it senses the ethanol in your blood just by you touching your steering wheel, and it's an electrochemical sensor, right? I'm using this equation to get it because my little sensor's measuring E cell, E0 cell, that's from the tables, right? And what's N again? Moles of electrons that cancel out. And then my ethanol concentration is in my Q expression, whatever my reaction is, that little sensor that I've developed that I put on your steering wheel. The ideas are limitless with this. It's really, really powerful stuff. So these were hard questions because pretty much you use this expression, then you had to solve for that ethanol concentration, right? You had to do a lot of rearranging to get there. So I think this is probably the toughest types of questions that are coming on this exam. And we'll see if we can do one of those. Using the table of standard reduction potentials, which oxidizing agent is better, chromium or tin? Not to give me the answer, just how do you answer it? Kendall, how do you answer that question? What's the game plan? You're going to need a table. Okay, good. Okay, and then oxidizing agents get reduced. So in that table, right, it looks like this. And electrons are always on this side. Okay, so you have reactants and products. We said oxidizing agents always get reduced. We better find chromium-3 and tin-2 on which side in this table? As a reactant or a product? As a reactant, because they're always getting reduced. Because if these questions are well written, which they probably are, this chromium and this tin are going to show up on both sides. So for people who don't know what they're doing, they're just going to, right? So you better find chromium-tin as a reactant on the left side, and then you look at the what values to see which one's stronger. The E0. Look at those E0s. The one that's the most positive is your strongest one. If the question would have been changed to reducing agent, do the exact same thing, but now these compounds have to be on the product side, the right side. And then your answer would be the one that's the most negative. Right. Because you have to flip those E0s. And then you just had a quiz on this last question. Okay. All the radioactive particles. Just make sure the sums of the superscripts and subscripts are the same on both sides of those nuclear reactions, and you'll be good. Okay. So we've got a bunch of these here. Probably just do like we did last time. We start at the beginning and work our way through, right? A voltaic cell has an iron rod in a 0.3 molar iron 3 chloride solution for the cathode and a zinc rod for the anode and a 0.2 molar zinc sulfate solution. The half cells are connected by sulfurage. Write the notation for this cell. So let's not only write it, let's also draw it. Do both. Do both. There's some conventions that you just need to remember. So write the shorthand notation and also draw the darn thing. And when they say draw it, they want to see the direction of the electrons, the ion flow, labeling all the parts, the anode, cathode, and all the solutions and electrodes. So in front of you, you should have the that table, because you're going to need it. I think you do. Maybe you don't, but it's helpful to have it. Right, that table of reduction potentials. I guess you really don't need it, but So hopefully in your shorthand notation, you're putting the anode on the left-hand side. Whether you're drawing it or writing the shorthand notation, then anode has to be on that left-hand side. Because they want the electrons to be going from the left to the right. Say, what did you write for your anode half reaction? Oh, you're drawing? All right. You want to have an idea for their anode half reaction? Zn solid going to Zn plus 2. You don't have much choice because they said that's your anode. And anode has to be oxidation. So that means it has to be getting oxidized. So that should be your, they didn't ask for this, but it's a lot easier if you recognize it. Because then it makes it a lot easier to write the shorthand notation. Then, do you remember how we separate the reactants and products in these cell notation? Either you used a what or a what? A comma or a line. In this case, it's going to be a line because they have different phases. Good. Cathode has to be reduction. Whoop, 0.3 molar. So for the shorthand notation, that should have been your answer. Make the anode on the left, cathode on the right. Make sure you have concentrations written in there. Pretty much it's the reactions, the half reactions. They just left out the arrows and the electrons. Okay, Mia, in my drawing, I have a few things that I'd take points off for. There's some things that are missing. What else should be on there in my drawing? Label the anode and the cathode. Label that anode and cathode. Okay. Oh yeah, good. Label this as my salt bridge. But I think one other thing you might be interested in is asking for the ion flow. What is it talking about? Ion flow. What's coming out of the salt bridge, right? Because you need to complete the circuit. So you have to have charges moving in a circle, complete circle. And yeah, their electrons are moving in the wires, but through that salt bridge, it's ions. It doesn't matter. Moving charge is current. So what ions are going where? What ions are coming out here, and what ions are coming out here? In the anode, let's say we have a sodium chloride salt bridge. That seems the most common and cheapest, right? So I hear people are saying chloride Cl minus is coming out of the anode salt bridge side. Does that make sense? Because you have zinc solid. The only way I can answer this is looking at the half reaction. I'm producing a bunch of these cations, right? If I don't have anions coming out, right, it's going to develop a charge. I'm going to like build a battery out of nothing. Well, that doesn't make sense, right? Balls don't roll uphill, they roll downhill. So I need to be canceling out that zinc ion I'm producing. So I agree with that. Chloride anions coming out of there. And then on the cathode, this iron plus 3 keeps disappearing and plating out, right? You get this hunk of iron, this fresh film of iron solid on that iron electrode, right? The zinc electrode, he's dissolving. He's getting nice and shiny. So if the iron plus 3 keeps, right, disappearing, well, I need to replace that positive charge. So my sodium ion would come out. Okay. So those are the pretty much, oh, look at the next question. Huh? So those are pretty much the parts that I was interested in. I should have just not changed the question, because look at the next question. We already did a sketch. We don't need to do all that again. But we could do this part. Let's cross out the sketch. Unless you can do it if you'd like, but it's a typical question. Notice how it asks for that direction, electron flow. Ion flow is not in there, but that should be in there too. Anyway, let's just do this first part. Write the half cell reactions and the overall cell reaction. And if you get it, go on to 84, because the answer's even there on 84. Because 56 I don't think is so bad, right? Just line up your arrows to make sure it's going good. Hopefully you multiply the zinc through by 3 and the chromium through by 2. So if you got it, go on to the next one. If not, just ask. In 84, they're looking for a equilibrium constant. And then your table doesn't have the necessary half reactions, so I'm giving them to you. So they want you to use those E zeros to get an equilibrium constant for that overall cell reaction. What does the question want you to get? Okay, so what mathematical symbol is that? Equilibrium constant is? That's Gibbs.
Wait. Is that K?
Big K.
Okay.
So you're going to have to use an equation with big K in it. So anybody get started on 84 and has a game plan? Out of this whole big mess up here, what equation are you going to use to work on 84? Yeah, E cell and the log K. You need the equation with big K in it. See if you can figure out how to get everything in there. Substitute, solve for K. Hopefully you'll get 8.3 times 10 to the minus 7 when you're all done.